Hello guys, welcome to Thinking Age online platform. So this is where we teach subjects online. Now, in the previous videos, we had been looking at the 5 circle theories and we are done with those. You can check out the videos. Now today we will be solving exam questions. So this is one of the past exam questions which appeared in the grade 12 internal exam. So you can check it out. Yeah, we're going to go about it. So without wasting time, let's start solving it. Now, the question reads, in the diagram below, A, B, C, D, those are the points which lie on the circumference of the circle with the center O. Now it says, given that angle DBC is 28 and angle BAD is 47 degrees. So calculate BOD. So we're going to calculate BOD, which is this angle here. And then question B says, calculate angle OBD, the angle there. And the last question says, calculate angle BDC. So BDC, the angle here. So that's the question you are told to find in an exam. Without wasting time, let's go. So I want to calculate angle BOD. Now, before you start calculating, I would advise that when you are dealing with the circle theory, before you look at it, try to analyze the question, see what you are given, so that you are able to bring in your mind as to what theory am I going to employ to calculate my answers, because that's very important. You have to identify which theories are applicable here. In the first thing, like I've been saying, whenever you are given the question, start with the first theory. Look for an isosceles triangle. Here, for me, I can see a triangle here. I can see a triangle DAB. This is a triangle DAB. I can also see another triangle DOB. And the last triangle I can see is BCD. It's also a triangle. So you have 3 triangles. Of those 3 triangles, the one which fits to an isosceles, remember, we said is formed when you have 2 radii. So I can see this radius here. I can also see this radius. So what I've seen, I formed an isosceles triangle DOB. DOB is my isosceles triangle. And then I can also see base angles, because if these are 2 lines which are equal in the isosceles triangle, then DB becomes my base. So I can also see these base angles here. These will become my base angles for the isosceles triangle. So meaning I can use the theories of the isosceles triangle. What other theory can I see? Remember, look at DB being a chord. And then with this chord we form 2 angles. There is the angle formed here. So this angle is formed by line DO and OB, starting from the same chord. I can also see another angle in the same segment formed by this chord DB, which is angle DAB. So here, what am I seeing? Am I seeing the theory of angle at the circumference 2 times angle at the center? You see, I can employ that theory that angle at the circumference becomes 2 times when it comes at the center. The angle at the circumference is this one, DAB, 47 is at the circumference. When it comes here, it will become this angle. It becomes 2 times. I'll use that theory. What other theory can I also use? I can see a cyclic quadrilateral. The cyclic quadrilateral in our case is DABC. DABC is a cyclic quadrilateral. Like we said in the theory when explaining the cyclic quadrilateral, I'll just look at the opposite angles and they should add up to 180. That's so. When I find those opposite angles adding up to 180, then I can calculate these others. These 3 theories I've talked about are the ones that we're going to use to calculate these questions. Okay, so let's start solving. So the first question says calculate angle BOD. So we're going to number 1, calculate angle. So number A says calculate angle BOD. So BOD, so we're calculating this angle. So how do we calculate this angle? For me, I want to calculate this angle using the angle at the circumference 2 times angle at the center. Look at this one. Angle BOD is the angle at the center. Remember our formula on this theory, we said angle at the center, which we represented in form of y, is equal to 2 times x. Where was this x? This was angle at the center, and this x was angle at the circumference. So in our case, we know that BOD will become our y, that's angle at the center. And then DAB becomes our x because it's the angle at the circumference. So how do you solve this one? I would say BOD is equal to 2 times angle DAB. That's all. I've written this theory or this equation in form of the angles I'm given. You can even give a reason: angle at the circumference 2 times angle at the center. So here it's very simple. What is BOD? BOD is equal to 2 times what is DAB? DAB is 47. So meaning angle BOD will be equal to 47 times 2. Okay, so this one will give me 4. This times 2, 8 plus 194 degrees. That's all. You have calculated your BOD. So angle BOD is 94 degrees. I can even write it 94 degrees. It's true. 47 becomes 2 times at the center, and it becomes 94. So I've calculated my BOD. Then the next question, which is question B. Question B was asking me to calculate angle. So what angle are we calculating? OBD. So we're calculating angle OBD. This angle here is the angle we're calculating. Now, for me to calculate angle OBD, I'll use, since look at this DOB. DOB is an isosceles triangle in which I know that this angle ODB, this angle, and angle OBD, they are base angles. So using that principle, we can calculate this one. And what did we say? We said in the same way, we said in an isosceles triangle, we have, if we say the two angles will represent them by x. So I'll say angle D. When I add all the angles here, they should give me 180 in this triangle. So I'll say which angle? Angle DOB plus 2x should give me 180. So some of you are wondering where this 2x is. This x is representing these angles here because they are equal. And I don't want to write them because they will confuse me, but I know that since these angles, they are base angles and they are equal in an isosceles triangle, I will represent them in form of x. So what do I have here? I know that DOB, what is my DOB? I have calculated my DOB to be 94 plus 2x is equal to 180 degrees. So here I have 2x is equal to 180 minus 94. Remember, I take the like terms the other side. So my 2x is equal to, when you subtract 180 minus 94, here you should get 86, if I'm not mistaken. So here to be 6. So remember 7. 17 minus 9, that's 8. So 86 degrees. Now I want to have x alone, we divide both sides by 2. So meaning my x is equal to, okay, when you divide 86 divided by 2, we're going to have 43. 43. Now remember, this x was representing any of the two angles. Therefore, my angle OBD is equal to 43 degrees. and I've calculated my 43 degrees. So I've solved that one. Okay, so the last question is calculate angle B. So we have BDC. Remember, so here we found that it was 43. So even here it's 43. Okay, so we are calculating angle BDC, meaning it's this angle we want to calculate. So for us to calculate this angle, it's very simple. Number one, we need first to calculate this angle first. This angle. After we calculate this angle, then we can add this angle plus this angle minus 180 because it's a triangle, then it will give us. So how do you calculate BDC? So pay attention here. For us to calculate BDC, we know that angle, so we know that when you add angle, BDC plus angle BCD plus angle DBC, these angles should give me 180. So these are the angles in a triangle. What triangle are we considering? We are considering this small triangle DBC. So when I add this angle, which is this angle, which is BDC, this angle plus BCD, this angle plus DBC, that angle, they should give me 180. I don't know this one because it's the one I want to find in the question. But I know which angle do I know. I know DBC. DBC, I know this one. But do I know this one? I can calculate this one. So I can find this one first. Because finding this one is very easy. How do I find? So once I find this angle, then I'm going to put it and then be able to calculate this angle. So how do I find BCD? I know that my BCD plus DAB should give me 180 degrees. Why am I saying BCD plus DAB should give me 180? Because look at the cyclic quadrilateral. The cyclic quadrilateral ABCD. Okay, so this is from a cyclic quadrilateral. Cyclic quadrilateral. And what did we say when talking about cyclic quadrilateral? We said opposite angles in a cyclic quadrilateral add up to 180. Look at BCD. BCD, this angle in a cyclic quadrilateral is opposite to this angle. So when I add this angle plus this angle, they should give me 180 because they are opposite angles in a cyclic quadrilateral. So what is BCD? I know BCD plus what is DAB? DAB is 47 degrees is equal to 180. So my BCD is equal to 180 minus 47. So my BCD is equal to 180 minus 47. So 47 minus 10, that would be 3. 4 minus 7, 3. So 133. When I add this, they should give me 180. So now, I know that BCD is equal to 133. But I haven't answered the question of BDC. It means when I come here now, I have known this one. It's no longer now I find. I have known this one. Was BCD is 133. Then using this formula, I can calculate BCD. I know that for me to find BCD, now I come here. Therefore, BDC plus BCD plus DBC should give me 180. I'm just writing this formula here. And what do I know? I know BDC plus, now BCD I know is 133 plus what is DBC? So DBC is 28. Should give me 180 80. So what is my BDC? So remember, these are angles. BDC is equal to 180 minus, now when you add these two, 133 plus 28, so what is 3 plus 8? That is 1. What is 2 plus 35 plus 1? 6. Yes, that will give us 161, if I'm not mistaken, because this plus this give us 11, carry 1. 3 plus 2, that's 5 plus 1, 6, then 1. And what is BDC? BDC will be equal to 180 minus 161. So this minus this will give me 9. So I remain with 7. 7 minus 1. So my BDC is equal to 19. And I've calculated. So in a nutshell, if you look at how we have found, we first found our question A, B word using the principle of angle at the circumference will become 2 times at the center. After we found this center, we used the principle of isosceles triangle and found the base angles 43. After finding the base angles 43, for us to find BDC, first we know that taking this small triangle DBC, we know that when we add all the 3 angles in this triangle DBC, will give us 180. But the problem is that we were given DBC, but we never had BCD. But we know that we could calculate BCD using the principle of a cyclic quadrilateral. After we found it, then we put it and here and calculated 19. That's how you could calculate this question. So very simple. There are other questions, you can check them out in the video. What is very important is understanding how you apply those circle theories, the 5 circle theories that we use. So if you have any question, any comment, use the comment box below to get notes. And remember, we have a live online platform where you can learn live and interact with the tutor dialect. So if you want to be part of it, just leave your details in the comment box. Thanks guys, enjoy.